Affective neuroscience examines how the brain creates emotional responses and aims to understand how the brain structures and chemical create such emotions. Emotions are a psychological phenomenon that involves changes to the body, changes in the nervous system activity, and changes due to act in specific ways. Emotional responses are revolved around the organism's survival and reproductive needs. Thus, emotions influence perception, cognition, and behavior for the organism's survival and thrive motive. Brain circuits located deep within the brain, below the cerebral cortex, and are primarily responsible for generating basic emotions. Humans, Human neuroscience must rely primarily on non-invasive techniques such as electroencephalography and functional magnetic resonance imaging, and beyond individuals with brains caused by accidents or disease.
The basic emotions involved in the neuropsychology of emotions and motivations is desire, liking, grief, fear, rage, and love. Let's start with desire, the neural system of reward seeking. Desire is considered as one of the most important affective neural systems that relates to the feelings of desire or the appetite for rewards. When the appetite system is aroused, the organism shows enthusiasm, interest, and curiosity. All the stimuli related to desire is seen in the left frontal cortex of the brain. Moving on with liking, the neural circuits of pleasure and enjoyment. Surprisingly enough, the amount of desire toward a reward does not correspond with how much he or she will like the reward. The scientific reason that backs this up is the neural structures involved in the enjoyment of rewards are different from the structures involved in the desire of the rewards. Furthermore, the area in which liking is focused on, the brain, is the area within the nucleus accumbens and the posterior half of the ventral pallidum. Next is fear, the neural system of freezing and fleeing. Fear is an unpleasant emotion that is geared to motivate the avoidance of potentially harmful situations. Slight stimulation of fear-related areas in the midbrain causes an animal to freeze, where else intense stimuli causes them to flee. The fear circuit extends from the central amygdala to the periaqueductal gray in the midbrain. Next, we have rage, the circuits of anger and attack. Anger or rage is an arousing, unpleasant emotion that motivates organisms to approach and attack. The neural networks for anger and fear are near one another, but separate. The network for rage extends from the medial amygdala through specific parts of the hypothalamus and into the periaqueductal gray of the midbrain.
States generate behaviors that result in specific benefits for the body, like how hunger makes individuals eat foods to increase blood sugar levels. Dry states respond in both internal and external cues. It has strong direct attention towards elements or activities to satisfy the biological need, like when people say, "I'm not doing anything until I eat first." It also produces a second form of attention erring, which is collapsing of a time perspective towards the present that causes us to be impatient when makes us demand things.
Now, let's go into depth about the key properties of drive states. Homeostasis. Humans, like all organisms, need to maintain a stable state in their various psychological systems. Most drive states motivate action to restore homeostasis using both punishments and rewards. Imagine that these homeostatic mechanisms are like molecular parents. When you don't behave well, such as not providing nutrients to your body, it resorts to punishing you by hunger. In contrast, if your body temperature declines below the set point, the action of moving to a warmer setting will send a signal of happiness or comfort to your brain, thus rewarding you. Now, let's move on to the second key property of drive states, the narrowing of attention. As the drive state intensifies, the person tends to direct attention towards elements, activities, and forms of consumption that satisfy the biological needs associated with the drive. Drive states also have a second form of attention narrowing, which is the collapsing of time perspective toward the present. Yet the third form of attention narrowing involves thoughts and outcomes related to the self versus others. When the drive state is very intense, it tends to narrow one's focus inwardly and undermine altruism or the desire to do good for others.
Hunger is triggered by low glucose levels, and there are internal and external cues that signify this. Internal is when your body breaks down fats and releases chemical cues that tells the body to look for food. External cues is determined by the time of day and the sight, smell, and taste of food, which causes a signal to the body to look for food. Sexual arousal is generated by internal and external mechanisms that are triggered by the extended absence of sexual activity or by the immediate presence and possibility of sexual activity. Male sexual arousal and pleasure is strongly related to the preoptic area, a region in the front of the hypothalamus. Female sexual arousal is mostly involved in the ventromedial hypothalamus, the lower central area, which plays a similar role in this as the preoptic area for males.
Overall, our day-by-day emotions, such as grief, fear, rage, and love, are all connected back to a specific region of our brain. All of these basic emotions are incredibly interrelated to our drive states of hunger and sexual arousal. Furthermore, our drive states even have two key properties of homeostasis and the narrowing of attention that stabilizes them in order to get your body what it needs. After our brief overview of the neuroscience of emotions and motivations, I hope it will bring a better understanding why you react the way you do when certain emotions are involved. Thank you.